going binary to decimal can be rather confusing. I'm going to help it make more sense for you. So here I have a quick example, and then I'm going to go through examples more and more. Let's say we have this number in binary. Now the key is you can sort of decompose this binary number into its powers of 2. Now the thing you need to be careful is that 1 is in the ones digit, which is also known as the 2 to the 0 power digit. That is 1. No matter what base you're in, that first digit is the ones place. So that's the 2 to the 0 place, which is the ones. And then you just go up. You have 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. Now keep in mind, some of these digits, there's nothing there. Let me show you what I mean. I'm going to just show you how I'm decomposing this. I'm just going to highlight all my ones. This means that we have, in fact, we have no 2 to the fourth, because that's turned off in binary. We also have no 2 to the first. So we don't need to consider them. 0 to any multiplied by anything is just 0. And then we can just clean up. 2 to the fifth is 32. I have that one memorized. 2 to the third, recall. That's 2 times 2 times 2. That's just 8. So we have 1, 8. We also have 1, 4. 2 to the second power is 2 times 2. That's just 4. And then we have our 1 in the ones place. We just have that unit on the end. And now we just add all of this up, and we just get 45. Now keep in mind 45 base 10. We typically just write that as 45. When we're just dealing with numbers generally. Don't forget, though, that truly is base 10. So you want to calculate the decimal value of each digit position. That's what we did. We broke it down. We essentially wrote down all the zeros and ones and then did our powers of 2. Then we cleaned up each little piece or part, added it all together, and we were perfectly in decimal. So let's just make up an example. Let's go binary to decimal. Let's say we have something really wild here. Let's say we have 4 ones followed by a couple of zeros and a 1. Now this is in binary. We're going to go to decimal, and we're going to do the same thing we did up here. Now I'll just write out these ones, and I'll give myself some space. I have 4 ones, a couple of zeros, and another 1. Now I can start writing my powers of 2. Again, I'm going to be right aligned. So I've got 2 to the 0, 2 to the first, 2 to the second. This is binary. It's just base 2. 2 to the fourth, the next decimal, the next binary place is 2 to the fifth, and then we have 2 to the sixth. And then all of this is just getting added up. Now keep in mind, our zeros, we don't need to consider them. Now we can just focus on our powers of 2. Keep in mind, the ones place. 2 to the 0 is 1. I got one of those. I have 1, 2 to the third. That's 2 times 2 is 4 times 2 is 8. I have 16. That's 8 times 2. That's my next digit. I got one of those. I got 1, 2 to the fifth. That's 32. And then 32 times 2, I have 164. Now we all know 1 times anything is just the anything. So we genuinely have a 64, a 32, a 16, an 8, and don't forget the 1. Now we'll just put these all together. I like to put them together in a strategic way. 64 and 16, that's going to be 80. I have 4 and 6 makes 10, and 10 and 60, that's 80. I'll put together these strategically. 32 and 8 is 40. And then I have one more. That's going to make 121 in good old-fashioned base 10. All right, let's do one more example here, just to make sure that it's making sense. Okay, so again, we're going to go from binary to decimal. This example, let's have it be 110, 1101. Now this is in base 2. We're going to convert this to decimal. So again, I like to just write out 1101. I like to write it out with some space. And now I'm just going to rip off my powers of 2. I'm going to start at the right. I have 2 to the 0 power, 2 to the first, to the second, to the third. I'm just counting up to the fourth, to the fifth, and to the sixth. All of these are going to be added together. Keep in mind, anything multiplied by 0 is just straight 0. Now I just have my powers of 2. I'm not even going to do 1 times it anymore. I've got a 64. I've got a 32. 2 to the third, 2 times 2 is 4 times 2. I have an 8. I have a 4. And keep in mind, 2 to the 0 power is not 0. 2 to the 0 power is 1. So I also just have this 1 on the end here. Now I can just put things together. What do I have? I'll make a 70. I'll make a 40. And I won't forget the 1. That's 111 in base 10. Let's just do one more weird one. Again, I just want to make sure this is making sense for you. So let's try one more. All right, so this one's going to be particularly weird. I have 1. Let's give myself a lot of zeros. I mean, this looks intimidating. This is in base 2, and we're going to go to base 10. We're going to go to decimal. So if you want, this is the 2 to the 0th power. This is 2 to the first. You just sort of write these here to the 3rd, to the 4th, to the 5th, to the 6th, to the 7th, and to the 8th. A lot of these powers of 2 are shut off. So I'm only going to consider the ones that are turned on. I have 1, 2 to the 8th. Oh, and I have a 2 to the first. I have 1, 2 to the 8th, and I have 1, 2 to the first. All the other digits in binary are shut off. They're just zeros, so we don't have to consider them. All right, so now we have 2 to the 8th power. And as a reminder, I have 2 to the 5th in my head. That's 32. So times 2 would be 64. Times 2 would be 128. Times 2 would be 256. Okay, so I have a 256 here. And then I have a 2. This puts us at 258 in base 10. Just as a little reminder, notice there was no 1 on the end. The 1's digit was 0. So we had a nice even number here. I hope that this was helpful converting binary to decimal, and I'm going to keep doing a bunch more videos on this. Feel free to like and subscribe. Have a beautiful day.